Okay, so you probably already printed out Unit 3 notes, and you probably noticed that it's quite lengthy. There's a lot of practice problems on here. This is going to be the same thing that we did prior with the kinematics, but instead of it being just kinematics and doing our math and side to side or up and down, now we're going to be doing the math, same equations, but we're going to be doing it side to side and up and down at the same time. Okay, and hopefully some of you kind of see this. I'm hoping that you see that it produces a right angle 90 degrees right here, and hopefully this is gonna be like a flashback of what does it create: a right degree 90-degree angle triangle, and a little bit of geometry is hopefully coming back to you. Okay, please go make sure you go ahead and put your name up here. Okay, so that way when I'm grading your papers, I have your name up there. Also, just for us, I like to do this every single time, whether we are in class or whether we are virtually. I like to make sure I write down important information on here. A couple of things that are important is going to be our calendar, right? We need to know when our quizzes are and when our tests are, and hopefully you keep your notes, your current notes somewhere near you, so that way you're able to quickly use them, because we're going to use them pretty much all the time when we have class. So let me go ahead and pull up Monday, Wednesday. If you're a Monday, Wednesday person, I'm going to go ahead and put it up here. Quiz. Monday and Wednesday. Your quiz is going to be on 10/7, October the 7th. Again, though, I've said it before. I'm going to say it again. It's getting to the point where those zeros are going to stay. We've had 6 weeks of school now. I've said it multiple times. It's in your calendar that's on Blackboard. It's on there. We have class during certain class time periods. So Monday, Wednesday, people, during your class time, we are going to meet during Teams first. After we have our meeting, then we're going to go ahead and take our quiz that day. If you are a Tuesday, Thursday person, then your quiz is going to be during your class time, which is going to be on 10-8. Okay, does not matter. It's only during your class time. So for those of us who forgot or something happened and you missed it, you're going to get the 0. That's it. I've been procrastinating, waiting too long. It's a fast-moving class. I want to show the pictures and have the answer key up there for everybody else, so that way they can see their answer key and just kind of go ahead and look through it. The other important thing that we need to know is going to be test. Test. Does not matter if you're Monday, Tuesday, or Wednesday, Thursday. For us, our test is going to be on 10-9. Every single person, 10-9. Again, this, I forgot, I slept in, is not going to cut it. It's a done deal, okay? You're going to start getting those zeros, and you're going to start paying for those through your grades for those 6 weeks semester report card grades, okay? So let's go ahead. We wrote down important information that we need to know. Let's get started with the notes. Yes, I'm going to be honest, there's a lot of notes for us to go through. Okay, in many different parts, video parts here. I'm sorry, but we're going to need to get through them, okay? Let's go ahead and start off with free falling or falling objects. Okay, the word free fall in physics is whenever we use that when we're talking about an object in the absence of air resistance. Okay? In the absence of air resistance. Now, we live here on planet Earth, and like, we're humans, so we have to do this thing called breathing air. Okay? And so when we talk about free fall here on planet Earth, obviously we're not talking about every single air molecule was removed and is no longer there. Because we have to breathe air, for us, free fall is, yes, truly it is in the absence of air. But because air molecules are so tiny that when we dropped objects near the surface of the planet Earth, they actually all fall with the same constant acceleration. Doesn't matter if you drop a penny or it doesn't matter if you drop an elephant. Okay? If they're dropped near. Now, I don't mean near as in like 2 feet above the ground or 6 feet above the ground or 15 feet above the ground. I'm talking about miles up, like an airplane. Okay? Like that height. Okay? We're talking about a big, like a tall building. And 2 objects were dropped from the tall building. That is still considered to be near the surface of the earth. Okay? That word near. Okay? So we're still talking about pretty darn high up, but yet it's still considered to be near the surface of the earth. And the reason why is because even from those distances, like the height of an airplane, a helicopter, or the tallest building here on the planet Earth, doesn't matter, because the gravitational pull is still going to be about the same. Okay, so we call free falling objects, yes, even if they're here on planet Earth, okay, we consider this to be in the absence of air resistance. Now, where would this truly be located at? In outer space, on the moon, okay, in outer space and on the moon. Okay, those would be that would be the best idea scenario. Okay, so let's keep going. It says here on the next part, demo. On Earth, where there is air, for an example, what if we're to drop an apple and a feather from the same height and allow them to fall to the ground? Well, again, remember last unit I told you that we're going to start getting to that point where we're going to start doing a lot of drawings. And if we were in class, I would have an apple and I would have a feather. But since we're not in class, let's go ahead and draw this out. We have a person here and they have an apple in this hand. And on this side, they have a feather. Okay? So here they are. They're here in class, or you're here at home. This is you at home. You have your apple and you have your feather. Look at their hands. Roughly, I don't have a ruler here in front of me. Here we go. I can get one. But I tried my best to draw it to where they're pretty much at the same height. Okay? But that's what it says here. So I'm just going to go ahead and pretend. I'm just going to draw in over here. The same height. I don't know, but this is 1 meter stick, okay? 1 meter high. So I'm going to assume that both of those, the apple and the feather, is being held up 1 meter high above the ground. Now, even though I'm not sitting here in class or in front of you at your house holding up an apple and a feather, you know from past experience what is going to happen if I was to drop those 2 objects at the same time from the same height. Well, the apple falls faster than the feather. Okay? Well, yeah, duh, Miss Munson. I mean, like, we're 16 years old. We know that if we drop an apple and a feather, they're both going to fall, but the feather is going to take longer to fall because of air resistance. You're right, air resistance. Okay? Now, again, though, we consider objects that fall near the planet of Earth to be considered in the absence of air resistance in the word free fall in physics. But that's when we're talking about objects like an apple, objects like a penny, objects like an elephant. If you threw an elephant off of a building and a penny off of a building, we're going to consider both the elephant and the penny when they're falling in what we call free fall, or in the absence of air resistance. Because as that penny falls to the ground, it is literally pushing the air molecules out of its way so it can fall. If I drop the apple, it also is going to push the air molecules because it has enough mass in it to move the air molecules out the way. But the feather is absolutely going to fall slower. Why? Because as it starts to fall down, we have all these air molecules that are like invisible to our eyes. Here they are, I'm drawing them around us, right? And so what happens is the mass of the feather is not heavy enough and it's spread out, okay? That whenever it starts to fall, the air molecules start to like hit it and slow it down, okay? Yes, I know this, but we've got to talk about simple step 1 before we go into step 2 or step 3 here in class. Let's keep going. Next part here, it says, well, why does it take longer for the feather to fall to the earth than the apple? Well, just like how we said, the air molecules, quote unquote, catches the feather. As it falls and slows it down. Okay? So it catches it, it hits it, it pushes it back, it causes it to fall, but slowly. Okay? The next part here talks about the moon. Now, I don't know about you, but me personally, I've never been there. So I'm just going to have to go off of, common sense that I have already, things that I've seen on TV. But is there air on the moon? Well, from what I can see, with everybody else who's been on the moon, like astronauts, no, there's no air on the moon, right? If there was, then why would they have all those spacesuits? So, will there be air resistance and then on the moon? No. Now that would be the perfect absence of air resistance or in free fall. Now, an environment, though, where there is no air present is called do we know what that word is called? Because I've used this word and I'm going to use this word throughout the school year, and I want to make sure you know what I'm talking about. In physics, when we use this definition, we're going to use this word right here. So in physics, when I use the word or say the word vacuum, I do not mean the machine that sucks up the dirt out of your carpet. Believe it or not, I've had some students who read the test questions and that's what they were thinking. No, when I use the word vacuum in physics, I am talking about the environment in which no air is present, and meaning that there's no air resistance. So when objects fall, they are falling in free fall because of the absence of air. There is no air resistance, okay? Just double checking, making sure that we're all on the same page. All right, so it says here now, let's go ahead and watch this video and let's talk about what happens. All right, so I'm going to pause this so that way I can I have the video pulled up on my computer ready to go. We'll watch the video. It's only literally 1.5 minutes long, and then we're going to go ahead and continue with the answers. Again, don't be upset. We're starting off with step 1 before we can move on to big kid physics, okay?